Hello everybody, welcome to the first lecture of ENGG 233. In this lecture I would like to give you an introduction to computer structure and also an introduction to computer programming. Computers are everywhere. We use computers every day, and I'm not just talking about using your laptop or your personal computer, but also when you use your smartphone, when you drive a car, when you use a GPS system, you are using a computer and interacting with a computer. That's why it's very important for us as engineers to grasp a good understanding of how computers function and learn how to communicate with them through programming. Computers have been around for a very long time, although they have gone through quite a lot of changes. If you look at computers around the 1940s, you see how large they were. They evolved throughout the years, and now we have our smartphones that fit in our pocket and are more powerful than the computers that were quite giant and could not even be fitted inside, could not even fit in a room. The internal structure of a computer is has remained the same for the most part, although it has evolved quite a bit. If you have been to the store and try to buy a laptop or a computer for school, a lot of the terms that we're going to be introducing in this video you've already heard before. So a computer is composed of four basic elements. The control, the CPU, which is the central processing unit, so it is the brain of the computer. You have memory. Memory can be divided into RAM and storage. RAM stands for random access memory, and it's basically the memory that the computer, it's short-term memory. So if you're running your computer, it's the amount of memory, the amount of information that the computer can remember at one time is stored in RAM. So the bigger the RAM, the more the more programs the computer can keep track of. The storage of the computer is how much you can store on that computer. So your hard drive or your hard disk would be your storage. So if you ever go to your task manager, you're going to see that the amount of memory or the amount of CPU usage for the computer is shown, and also the amount of disk usage, which is our storage. So you kind of see the programs that I'm running right now. I'm running PowerPoint, I'm running Windows Explorer, Screencast-O-Matic, which is the software I'm using to record these record my screen. They're all loaded and they have all been allocated an amount of memory to use. So and that's how the computer functions. So if you go to the store and you want to buy a computer, if you want to buy a computer that has a very, very strong CPU but it doesn't have a lot of RAM, then that's going to be the bottleneck of your computer, because your computer can think really fast but it can't remember as much. Vice versa, if you have a lot of RAM, so you can remember a lot, but your CPU, for example, is a Pentium, so it's an older CPU, then it can't process things as much. So you need to balance all that to be able to have a decent computer that can remember a lot of programs and also process them fast. So the two kind of go hand in hand. The storage is the same way, and that's how we basically communicate with the computer. So you can kind of see the hardware here. This is a strictly software course, but if you're interested in the hardware, I do have a picture that kind of outlines everything in terms of what is the hard drive. You have the motherboard of the computer and your input-output devices, which is the fourth component of a computer. So basically, the architecture of the computer actually works like this. So you have your ports and your controls, you have your input-output devices, such as your mouse and your keyboard and your printer, your monitor, speakers. You have your network you connect to internet with. You have your CPU, your random access memory, and your drivers, and they're all communicating using these vertical lines that we've drawn called a bus. So basically, these devices, they all communicate with one another through signals. What are these signals? The signals are a series of digital signals, meaning it's either on or off. So either 1 or 0. And that's why I'm sure you've heard saying that computers can only understand ones and zeros. This is what you're talking about. So if you want to communicate with your program, communicate with your computer, your program essentially needs to be a series of ones and zeros. Now, then what is a computer program? As you can imagine, series of ones and zeros could be easy for a computer program. For a series of ones and zeros are easy for the computer to understand, but then it's not easy for us to understand. That's where a computer program comes in. So a set of instructions written by a programmer using a particular programming language that can be translated or compiled to machine language is called a computer program. So essentially, you have your computer program, and this computer program is compiled, meaning translated. So translates to a series of ones and zeros, which is called machine language. And then the computer can understand and execute these commands. Now, how this is done is going to be a little bit different depending on what kind of a programming language you're using. But for the most part, this is the theory. So you have a high-level programming language that human beings can understand, and it makes sense to them with a series of commands and a series of function calls. And we'll talk about that in future lectures. These instructions will be translated to machine language. So a compiler actually is another program which takes this, compiles it, and translates it to machine code. Now, that's interesting. What happens if the compilation fails? That is, what happens if the compiler cannot translate the code properly from your programming language to machine language? Then we end up having a bug. Interesting fact, the first time there was actually a real bug. There was a moth stuck in the machine that caused a problem with execution of a program in 1945. So the term has been coined ever since. So when there is an error in your code, it cannot be translated properly to machine code, and you get a bug. Now, it is important. So this procedure is the same no matter what programming language you're using, but it is important to note that for this course, we're going to be using a language called processing. We're going to talk about that quite a bit, and we'll write a lot of programs in it. In the next lectures, I'll discuss that. In the next lecture to come, I would like to talk to you about machine code and how machine code works and what it is all about. Thank you very much.